So yesterday we studied about electrolysis of molten ionic compound. Let me revise it for you. In electrolysis of molten ionic compound, the negative part, the non-metallic part of ionic compound, the non-metallic part of ionic compound, the negative part of ionic compound was attracted towards the positive electrode that is connected to the positive terminal of battery, and the non-metallic part of ionic compound was oxidized at the anode, the positive part, right? Similarly, the metallic part of ionic compound, the positive part of ionic compound was being reduced at the oppositely charged, that is the negative portion, the negative part, the negative electrode of the electrolytic cell, right? So, and in this way, the molten ionic compound was being separated into its respective oppositely charged ions. Or in other words, we have just splitted yesterday ionic compound into its respective elements. We have taken an example of lead bromide. We have taken molten lead bromide and then split it down and then broken down through with the help of electricity, with the help of conduction electricity, into lead metal and bromine nonmetal. Now, today we will be studying about electrolysis of aqueous solution of ionic compound. Aqueous solution mean in which, yes please.
सर जो प्रोडक्ट्स बनते हैं इलेक्ट्रोलिसिस के वो हमेशा गैस के फॉर्म में होते हैं?
No, doesn't necessary. It is not necessary. We will be looking in the next cases that it can be gas, it can be solid deposit, or it can be in the liquid form. But if you are going to increase the temperature, or in molten cases, or if heat is being provided in some questions, then of course the liquid produced will be converted into gas, right? But we will be discussing for each and every case in later topics. So aqueous solution is a solution in which solvent is water, or water is solvent, right? In which water is acting as a solvent, or in other words, when any compound is being dissolved in water, then it will be the aqueous solution. Now, aqueous solution can be concentrated or it can be dilute solution. Concentrated means more solute, in this case, more ionic compound and less solvent like water, right? Whereas in case of dilute, it will contain less solute, right? Like ionic compound in this case, and more solvent like water. For example, concentrated solution, let's assume that, let's suppose we have 10 ml water, and suppose 15 or 15 grams have been dissolved in 10 ml of water. Whereas in this case, for example, there is 500 ml of water and only 15 grams have been dissolved. So this one will be dilute because it has more solvent, whereas this will be concentrated because the solution has less amount of solvent, right? So today we are going to electrolyze the concentrated ionic compounds. Then in the next class, inshallah, we will be discussing about the electrolysis of dilute ionic compounds. Now the first one is electrolysis of brine. Electrolysis of brine. Now what is brine, by the way? Brine is the concentrated solution of sodium chloride, the table salt. Now again, we will be using a simple container. We will be pouring concentrated solution of NaCl into it. This is concentrated solution of NaCl, and we know that in this solution Na is metal, so it will be present in this concentrated solution in the form of Na positive, whereas Cl is non-metallic part, so it will be present in the concentrated solution as anion, the negative part. Now we are going to add two electrodes, inert electrodes, which will not be reacting with any of the reactant, any of the solute particle or any of the solvent particle. We have used two electrodes, water electrodes. They are made up of graphite. We have studied that in our previous class, that they are made up of graphite. They are inert in nature. They will not react with the reactants or the solution, and they are being used to flow electrons into the solution, flow current into the solution, or to remove electrons from the solution, or flow out of the solution, flow current out of the solution, right? So the negative portion, sorry, the electrode that is connected to the negative part of the battery will be called as cathode. We have studied yesterday in our previous class. Similarly, the cathode that is the electrode that is being connected to the positive terminal of battery will be called as anode. Now, it will have positive in affinity, whereas it will have negative affinity, right? Now, as we on the switch, there are two possibilities. And also, remember that as it is the aqueous solution, as water is present in the solution, now water, after passing electricity, water can also split in H positive ions and OH negative ions. In other words, we will be having H positive ions, OH negative ions, Na positive ions, and Cl negative ions. We will be having two type of cations, Na positive and H positive, right, in the solution, whereas we will be having two type of anions, Cl negative ions and OH negative ions. But we also know that as it is concentrated solution, so the number of particles of chlorine anions, chloride ions, right, will be much greater as compared to the OH negative ions. Same is the case with hydrogens. The H positives will be lesser as compared to the Na positive ions. Now what will happen? Which ion will go towards, will move towards which electrode? We will be discussing that in this topic. We know that chloride ion will be rushing towards the anode, and also OH negative ions will be attracted towards the anode. Now there are both possibilities. We discussed yesterday in our class that at anode we know that oxidation takes place, right? Oxidation takes place, and oxidation is the loss of electrons, right? So there are two possibilities. O negative ions can lose electrons, and also Cl negative ions can also lose electrons. Now, which one will win the match, win the competition? Either chlorine will oxidize or OH negative will oxidize. We will clear this question in our later topic. That is, whenever there is comparison between halogen ion and OH ion, then halogen, in other words, chlorine will be oxidized first. Why? We will be discussing that later in our next classes. Just for the time being, for this lecture, just remember that Cl negative ion will win the comparison and will oxidize itself, and OH ion, although they will, OH negative ions, the hydroxide ions will be attracted towards anode, but they will not be oxidized there. They will not lose electron. So which one will lose electron? Of course, halogen. When halogen are present, then halide ion will be oxidized, or it will lose electron. So one chloride ion loses one electron, whereas we know that chloride ion, or in other words chlorine, exists in the form of diatomic molecule. So we need two chloride ions to lose electron to form chlorine gas, right? And two electrons will be lost. So in other words, over here some chlorine bubbles will form at anode. We can capture this chlorine gas, and this chlorine gas can be used to make bleach. So chloride ions will be oxidized at anode. Two chloride ions will collectively lose two electrons and will be forming chlorine gas. We have discussed that also in our yesterday class. Now there is comparison between OH positive, H positive ions and Na positive ions. Of course, both will be attracted towards the cathodic part. Then Na positive will be attracted towards cathode, whereas H positive ions will also be attracted towards the cathodic part. Now what will happen? Which one will gain electron? What electrons? The electrons that are being released from chloride ions. These electrons will be traveled throughout the external battery towards the cathode, right? So these two electrons were continuously coming from the anodic part, and from chloride ions basically were losing two electrons, and these electrons were transferring throughout the battery towards the cathode part. Now, which one will win the comparison match? Either H positive or Na positive. Now, we have discussed that also in detail, the reactivity series. Remember the reactivity series, and that is, please stop. Remember calling me cute zebra, right? I guess like hot coffee and sip in gold. Remember, this is the reactivity series. We have just learned that. Please stop P for potassium, Na for sodium, calling me a cute zebra. I love or like hot coffee sip in gold. Now, carefully look at here. Hydrogen is present over here, right? And sodium is present over here. We know that reactivity decreases down the group, right? This is the reactivity series. The reactivity decreases down the group, which means that Na is more reactive, whereas hydrogen is less reactive. More reactive means more able to oxidize, right? In other words, more able to lose electrons. Oxidize means lose electron, remember? Or conversely, less able to reduce, less able to gain electrons. More able to oxidize means more able to lose electron or less able to reduce. Similarly, less reactive means less able to oxidize. Oxidize means loss of electron, or more able to reduce, more able to gain electrons. So which one has more capacity to gain electrons? Hydrogen or sodium? Hydrogen, right? It has less ability to gain electrons because it is more reactive, whereas the hydrogen is more reactive, which means hydrogen is less reactive, which means it has, although less able to gain a loss electron, but it has more ability, more tendency to gain electrons, right? So of course hydrogen will be reduced. Hydrogen will gain electron to form hydrogen gas. Hydrogen will first gain electrons at cathode and will be reduced to form hydrogen gas. Is it clear? And sodium will not be produced. So we can say that there will also be some bubbles forming at cathode, and that bubbles will be of hydrogen, and we can use hydrogen in margarines to convert into ghee. To convert oil into ghee, we can use hydrogen gas, right? Whereas the chlorine gas, we can use chlorine gas in making bleach. Now, what type of ions are still left in the solution? Tell me, please.
So Na positive.
Na and
Yes,
OH.
yes, excellent. Na positive. Let me write the reaction at anode, cathode as well. At cathode, what will happen? Of course, reaction will happen. Reduction means gain of electrons. So one H positive will gain one electron. And also, as we know that hydrogen exists in the form of H2 gas, so two hydrogen ions or protons will gain two electrons to form hydrogen gas. To form what? Hydrogen gas. This was the aqueous solution. So aqueous solution, aqueous state, so it will be producing hydrogen gas, right? So what ions are still present in the solution? One is Na positive and another one is OH negative. Both will be reacting together to form what?
NaOH.
Of course, NaOH, the caustic soda, right? And NaOH is being used in soaps, in detergents, in shampoos, and all that stuff. So this was the electrolysis of brine. Is it clear, dear students? Yes, please. We can collect it. I have just draw a simple diagram for you to understand. You can place the inverted gas cylinder or the gas range, right? So you can collect the gas as well. There is nothing difficult in collecting the gas. Yes, what was your answer question?
सर जो चीजें रह जाती हैं उनकी इलेक्ट्रोलिसिस नहीं होती?
Electrolysis, what is electrolysis? The splitting of
Yes.
we have just split it. We have splitted sodium chloride into Na positive and Cl negative. Cl negative have been converted, the chloride ions have been converted into chlorine gas, whereas the sodium will be converting into sodium hydroxide by reacting with the remaining particles, that is NaOH. So after electrolysis, you will get the sodium hydroxide, the pure sodium hydroxide in the container, because all of the chlorine gas have been released, all of the hydrogens from the water have been released. Now which one has been left? Of course, Na positive and OH negative both will react with each other to form NaOH. Next question, please. No? Excellent, excellent. Any other question?
सर वैसे इलेक्ट्रॉन फ्लो पॉजिटिव से नेगेटिव की तरफ नहीं होता?
Who told you that? Remember, the direction of conventional current is from positive to negative, right? The only direction. And also,
Yes, sir.
the electrons are always flowing from negative terminal of battery. You can, of course, confirm from your physics teacher, respected physics teacher. In chemistry, you will have to learn the concept like that.
सर चैट जीपीटी भी कह रहे हैं पॉजिटिव से नेगेटिव.
No, the direction of current is from positive to negative, whereas the flow of electrons, the actual current flow, the flow of electrons is always from negative to positive, right? In case of electrolysis apparatus, you can watch some YouTube videos for that. Consult to the notes that I have been provided. You can check your book. Clear? Because at anode, oxidation takes place. Oxidation means loss of electrons. Electrons will be flowing from anode towards cathode, and cathode reduction will takes place, right? The positive cations will be gaining electrons at cathode and will be reduced. Clear?
Yes, sir.
Then I hope you have gotten clear concept. So take care, have a good sleep. Allah Hafiz.
Allah Hafiz, sir.